Hello friends, welcome to our engineering graphics YouTube channel. Friends, in this session, we are going to solve a problem based on projection of plane, and in today's session, we will solving problem on isoscale triangular plane. And the problem statement is an isoscale triangle base 50 mm and altitude 80 mm is resting in HP on its base. Its surface is inclined to HP so that the corner opposite to the resting side is 50 mm above HP. Draw the projections if its resting side is inclined to VP at an angle of 50 degree. Now here in this problem statement, isoscale triangular plane is given. Its base is 50 mm and this altitude is 80 mm is given. Now friends, here this isosceles triangle is resting on its base 50 mm side. So here we assume that the plane is completely resting on the horizontal plane in a stage 1, and in the second stage the resting side opposite corner is above the HP at 50 mm. Now here in the second stage the the corner, its locus is given, it is 50 mm. In this case, in this problem, no theta plane angle is given, but the condition is given, the resting up the corner opposite to the resting side is 50 mm above HP. So this corner is 50 mm above HP. Next condition is given, draw the projection if its same resting side is inclined to VP at an angle of 50 degree. So friends, here 5 plane angle is given. It is 50 degree. Now see the solution of this problem. It's a very simple problem. So draw the XY line first. So we are solving this problem in multiple stages, and for last stage we are using auxiliary plane method. You can solve this problem by using change of position method also, but change of position method is a time consuming, it requires more time. So we are planning to solve this problem by using auxiliary plane method. So draw the isoscale triangular plate first. Below xy, this is a xy axis. Below xy, draw the true shape of this isoscale triangle. So the base edge distance is 50 mm. Find the midpoint of this 50 mm distance and draw the altitude. Altitude is perpendicular to the base. Altitude is 80 mm. So mark a 80 mm altitude. Here we get a corner of this triangle, isoscale triangle. Now join altitude and base. So give the naming. This is point A, B, C. So you can give the dimension. Base is 50 and altitude is 80 mm. 80. This is 50. Now this is a stage 1 top view. For front view, project all the points on a XY. So friends, here we assume that the plane is resting on the horizontal plane. So in the front view, the line view we get on XY because plane is resting on the horizontal plane. So take a projection. So this is A dash B dash projection. A dash B dash is coincide with each other. This is C dash. Now, in the next stage, this is stage 1. In second stage, the whole surface inclined to HP so that the corner opposite, this is the corner C, the corner is 50 mm above HP. So for this problem, draw the 50 mm locus line. Draw the 50 mm locus line, thin line. So near the stage 1, mark a random point, give the naming. This is A dash, B dash. In the problem statement, AB side is resting on the horizontal plane. So this condition is satisfied here. Now we have fixed A dash B dash. Now measure A dash, B dash and C dash distance in compass, and from A dash, B dash mark a arc on 50 locus line. So friends, here we get a C dash point. By using compass, we just join this arc, mark a arc on this 50 locus line. Directly we get a C dash point. This is a theta plane angle, and the distance is, this distance is 50 distance. Now this is a second stage front view, but for top view, project, take a projection from front view, take a perpendicular projection. All these projections are perpendicular to xy plane. Now project horizontal projection from stage 1 top view. You can see this is a dash B dash projection line. This is a C dash projection line. Horizontal projection line meets here. This is your point A. Horizontal B, vertical B meets here. This is B and this is C. Now follow the sequence. Join AB, BC and CA and C. Now the next condition is given, last condition is given. The same side, the same resting side is inclined to VP at an angle of 50 degree. Now compare the stage 1 top view and second stage top view. In stage 1, the AB distance is 50 In second stage, the same AB distance is there, 50 is there. So in this problem, no need to find beta angle. So directly we can extend AB, and on this we can select a point, and from this point we will mark a 50 degree angle. Now from this direction, clockwise direction, mark a 50 angle. So this is a new plane. This plane is called as a auxiliary inclined plane. So you can give the naming. This is x1, y1. This is a AIP. Now observer is looking from this direction. Then observer will get a final view. Now project all these points, all 3 points in front of x1, y1 plane. So for that, adjust the ruler along x1, y1 and take a perpendicular projection. This projection is perpendicular to x1, y1 plane. Move the ruler in the forward direction and take a projection of A and C. All these projections are perpendicular to x1, y1. Now here, mark A dash, B dash and C dash in front of x1, y1. So here friends, for this final view, measure the dimension above xy plane. So here A dash, B dash is on xy. So here, this is a projection of A. So we can directly mark point A dash here, and this is B dash point. Now with the help of compass, measure this xy to C distance, measure this distance in a compass and mark this distance on a projection of C. So this is the projection of C. Here we get a point C dash. Now join all these points by using sequence. So this is ABH, join BC and CA and C and C. So this is a complete solution of this problem. So friends, for this problem, practice is very important. So try to drawing this problem yourself. See you in the next lecture. Thank you for watching this video. Happy learning.